Die, Cloud.
Hey guys, Cloud Killer Koopa Troopa here, and today I am going to do something a little different than most of my videos. I'm going to actually do kind of a tutorial on how to make solids of constant width in Fusion 360. So first of all, what is a solid of constant width? Well, according to Wikipedia, in geometry, a surface of constant width is a convex form whose width, measured by the distance between two opposite parallel planes touching its boundary, is the same, regardless of the direction of those two parallel planes. So this means you can have a solid that is not necessarily a sphere, although a sphere does qualify as one, that you can put on a table, say, and then roll a flat thing on top of it, parallel to the table, and it will roll like a sphere. Now, this might seem impossible, but if you look up some examples just on Google Images, stuff like this, all of these will do as it described. Now, how do we make one of these? Well, let's go ahead and launch Fusion 360 here. First off, we're going to need to create a tetrahedron. And I also have a Wikipedia page open on what that is, and we'll be using some of these fancy, scary, mathematical-looking measures in our creation. So, to start off with, we are going to need an equilateral triangle. I'm going to make mine with 50mm side length because I'm actually making this for a friend and he requested that. So, create a sketch on this plane. So now we have our equilateral triangle, but we want the center of the triangle to be at the origin. So, to do that, we need to find the center of the triangle, and we can do that easily by just drawing a couple of altitudes, and then if we draw a circle starting at the origin and radius to the center, then we have this length that we can do that with, and that is where the new bottom of the triangle should be. There we go. Now we've got our equilateral triangle at the origin. So, now we need to extrude it, and the height of this pyramid, the square root of 2/3, and multiplying it by the side length. Luckily, Fusion is awesome, and we can literally just type that equation into the parameter. So we go 50 times square root of 2/3. And that is our height. New body. Boom. So now we need to make this into an actual pyramid instead of just a triangular prism. So what we're going to do is modify draft. And this will kind of rotate faces around an axis. So using this plane as a reference, we're going to rotate this one, and this one all around it. And that angle, referencing the Wikipedia page again, it was face, edge, face, angle. So arctangent of 2 radical 2. Now, this is actually incomplete because if we just did that, it would look really weird and I don't want to do that. So, as you can see, it actually bends outward. So if I did like 10 degrees, you can see how it's bending outward and stuff. So if I do negative 10 degrees, then we start to get our pyramid. But that angle measure is a measure from this plane to this one. So we actually want to go negative 90, which it gives an error because it's trying to put all of these faces directly parallel with this plane, which would result in 0 width. But from there, then we can add this angle. So we go plus a tan of 2 times square root of 2. Yes. And there we have our perfect little equilateral pyramid, or tetrahedron. So now comes the fun part, making it a solid of constant width. So, what we're gonna do to start off is draw a circle, and since it's at the center, I can just do center, and then make the radius the same distance to the vertex. So now we have a circumscribed circle. Now what we really need from this is the diameter of that circle, so I'm going to just draw a couple of lines here, and then we can actually get rid of this circle. So now what we're going to do with that, since we need basically a sphere whose center is on this vertex and extends so that it is the same radius as these side lengths. The reason we did that circumscribed circle is because now what we're going to do is sketch a center point arc, because we actually don't need that full circle around there to simulate the sphere, but we just need a part of it. So we're going to sketch along this plane, and then set the center to that vertex, and then from here to here. So now we have that, and then we're just going to put a line down the middle. You'll see why in just a moment, and close it off like so. So now that we have that, that's the basic cross-section that we need. So we just need to take like this plane and just kind of rotate it around that axis, and that'll give us the shape we need. And luckily, we can do just that with a little command called revolve. So we're going to select the axis as this, and boom, there's our shape. So we're going to select new body, and there we have our shape. So you can see how this is kind of starting to take form. We're just going to need to do that for the rest of the sides. Now this side, we're going to take basically the same method, except this time I'm going to do a 3-point circle, since we actually don't know where the center of this triangle is, but we can go boom, 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 and now we have a circumscribed circle just like before. So now we just go to the center of that circle, boom, boom. And now it's the Deathly Hallows. We can get rid of this, stop sketch, and now if we go to view it in the right, then we can sketch our center point arc on this plane, center, boom, boom, and then draw our line down the middle, where's the midpoint, and a line to close it all off. Now we just do that same revolve command, select that as the plane, that is the axis, new body, and boom, there's our next side. Now, you might ask if we have to do that for all of the sides, but the answer is no, because there's a little shortcut we can use called pattern. So I'm going to show the origin, and what we're going to do is say circular pattern, and we're going to do this to the body. And what this does is it creates copies of this body in a pattern around an axis. So we're just going to select this axis, and boom, automatically sets it to 3, and there we have our sides. So now we have the basic shape of how this is going to go. We just need to like shave off some edges here. Now, the most obvious way to do this might be to just kind of create a projection of this face right here and just intersect it with the curve and stuff, which would get you part of what you need, but that would then leave the edges exposed because it's parallel, and you get what I mean. So we need that intersection first. So what we're gonna do is just make a copy of all of these so that we can modify them without hurting the originals. And then we are going to use the combine tool with a nifty little mode called intersect. So we're going to do this as the target and these as the tools, and that will just create a body of the area wherever these intersect. So we're going to do keep tools because we're going to need to do this to all of them. So we're just going to do boom, and boom, and then we can not keep that one. Hide this. So now we can go ahead and combine all of these into one body, and we will save that for later. Now we get to create our little projections. So to do this, we're going to use a tool called press pull. which is one of the most famous tools in Fusion 360, and you can use it to basically create an extension of any, well, not any, but a lot of faces. So you can do stuff like that. So what we're going to do is make a copy of this so that we can make changes to it without hurting the original. Select that bottom face, show this, and then we just need that projection to be past that point, the radius of the sphere. So 10 millimeters looks good, nothing showing through. So we're going to do OK, and then simply intersect these. And there we have our first projection. So if we show the body, you can see that that is about the shape that we need. So now we are just going to save that for later and do the same thing for one of the sides. And boom, now we have our second projection. So now what we can actually do is the same pattern trick that we did before. So if we do create circular pattern around this axis, boom, now we have our other two projections. And you can see what I was saying with these edges being exposed, so I will show you how that's going to get solved in just a moment. Let's see, we don't need this or this, so we can remove those, and then show this, and that is basically our solid of constant width. Now we just need to combine all of these. So if we do join, select everything here, and boom, that is our solid of constant width complete. Now, the cool thing about this is you can still modify this. So this would make a great print as is, but let's say you wanted to get weird with it. Let's see how it handles that press pull on one of these faces. So you can do weird stuff like this. Oh man, that is just strange. You can create like a weird football type shape with it, and theoretically this should still, like, if you only roll it along this axis, it should still roll like a sphere if you put it between two planes. Or like, let's see, what else can I do to this? We can shell it out, so we can make it hollow like this, and it's no longer constant width, but it looks cool. So let's see, what if I wanted to like make it a cage? I'm just gonna make a copy of this. Boom, there's our weird little cage thing derived from a solid of constant width. So yeah, this would also make a cool print. Let's see, what else can I do with this? Oh, that's actually kind of weird. That's actually cool. I'm gonna keep that. Oh, that's cool. That would make a cool print right there. So there you go. Solids of constant width. They're pretty cool and fun to play with. I will put a link in the description to download the STLs for all the stuff that I made today, including the main solid of constant width, the cage thing, rocket ship thing, and the weird, I don't even know what this is, but it's cool. So yeah, thank you so much for watching. I hope this was helpful for you, and if nothing else, I hope it was interesting. I may or may not do videos like this again in the future, but for now, thanks again for watching. Cloud Killer Koopa Troopa out.